Today we're going to be talking about vector addition. And there's two different ways you can actually add vectors. One way is the graphical method or tail to tip method. And the second way is a mathematical method using algebra and trigonometry. Today we're going to focus on the graphical method. But before we do that, let's talk about what is a vector. Remember earlier in the course we talked about vectors versus scalars? And a vector is any quantity that has both magnitude and direction, where a scalar only has magnitude, only has a number. So a vector is any quantity that has magnitude and direction, like displacement, like velocity, like acceleration, force. All of those quantities are vectors. They have a magnitude, a number with the units, and a direction. So what we're going to do today with the graphical method is we're going to use an arrow to represent a vector. And the length of that arrow is going to represent the magnitude of that vector. And then the direction of the arrow, if I put it at 15 degrees or 40 degrees or whatever, that's going to indicate the direction of the vector. Because we got to indicate both magnitude and direction. So let's get started. So I've got a problem on the board. So I want to add two vectors together. And these are going to be displacement vectors because it's kind of easy to work with. People can visualize it easy. So I've got one vector, one displacement vector. Its magnitude is 3 centimeters and the direction is 50 degrees from the horizontal. And I want to add that vector to the second vector, which is 4.5 centimeters at 15 degrees. So let's go ahead and get started. And the easiest way to do this is if you actually have a piece of graph paper. I don't have that on the board, but we're going to go ahead and do our best. So what I'm going to do is I'm going to use this meter stick, but you'd want to use a ruler, and I'm going to draw an X and Y axis. That's where we're going to start. So I'm going to draw an X-axis and a Y-axis, and they don't have to be that big. That's not too important. But we need a starting point. So the origin right there, in fact, I'll actually put a little dot there because that's where I'm starting. That's going to be my origin. That's going to be my starting point. And my first vector is going to be 3 centimeters at 50 degrees. So I'm going to get my protractor, and this one has a little tiny hole at the bottom, most do, and I'm going to put that right at the origin, right at the origin. So there I go. I'm going to line up the horizontal line with my horizontal axis, and I'm going to line up the 90-degree mark with my vertical axis. And then I'm going to go ahead and put a little dot at the 50-degree mark. So let me go ahead and get this set up again. So we got 20, 30, 40, 50 degrees right there. I'm going to put a little dot. Now I can go ahead and draw the magnitude of my vector. Now it's 3 centimeters. I'm going to make this a little bit bigger than 3 centimeters. You're going to want to measure 3 centimeters using a ruler on your graph paper. I'm actually going to draw 30 centimeters so that you can see it on the board. I'm going to kind of increase everything by a factor of 10. So here I go. Start at the origin, and I'm going to draw a vector that's 3 centimeters long. There it is. And at the tip, I'm going to put an arrowhead. Again, we always represent a vector with an arrow. And an arrow has an arrowhead. Now I've got to label this. And I'm going to go ahead and I'm just going to call it X sub 1. And that's going to equal 3 centimeters. That's the magnitude. And then the direction I'm going to illustrate with theta. So theta equals 50 degrees. So I got my magnitude and my direction. Make sure you label the vectors accordingly. Now what I'm going to do is at the tip of this arrow, not here, not at the origin, at the tip of that arrow, I'm going to go ahead and I'm going to draw another X and Y axis. And I'm not going to make it too big. So there we go. And there we go. Now this is where I'm going to start my next vector, 4.5 centimeters at 15 degrees. So I'm going to come up here, put the little circle right at the origin, line up the x-axis with my horizontal line, my 90-degree mark with my vertical line, and I'm going to put a little dot at 15. So I got 10, 20, right between the two, that's 15. And again, I'm going to draw a line that's 4.5 centimeters long. So I go right to the origin, right to the tip of the arrow, and I'm going to go ahead and draw 4.5 centimeters. And I'm going to make it 45, but you'd make it 4.5. A little arrowhead. And I'll call this X sub 2. And it's 4.5 centimeters in magnitude. And I'm going to indicate the direction right here, relative, again, to the horizontal axis. And I'll call that theta sub 2. I probably should have called this one theta sub 1. Theta sub 2, 15 degrees. So I've got my two vectors that I want to add together. Now what I'm going to do, and I'll do this in red, just to make it stand out a little bit better, but you continue to do it in pencil. I'm going to draw a red dot right where I initially started. And then I'm going to draw another dot where I finished. And then I'm going to connect those two dots. And you want to do this very carefully so you come out with an answer that's pretty close to what it should be. So I'm going to illustrate this with a dashed line, a dashed arrow actually. Now, my answer is also a vector, so I really should draw an arrowhead, and I'm going to label this vector R for resultant. That is my answer. That is my resultant vector. And what I want to do, this is going to represent the magnitude, is I want to measure from the origin where I started initially to where I ended up. And I want to measure that very, very carefully. So when I do that, what I got was 7.2. So I'm going to write 7.2 centimeters. And then I also need to know the angle. And I'm going to measure this relative to the initial horizontal axis. So I'm going to go ahead and draw a little curved arrow. Theta sub R, my resultant angle. And that should be approximately 28 degrees. 28 degrees. And I'm going to get that by using my compass. I'm sorry, my protractor, if I can pick it up. And sometimes they're not very easy to pick up. So I'm going to go ahead and line everything up. And when I do, 28 degrees is what I read. I'm going to put a little box around that. That's the magnitude, and that's the direction of my resultant vector. And that's it for the graphical method.